Have you ever wondered how a smart pole in a smart city works and the amount of sensors and the amount of capabilities that are in there? Well, we'll talk about that and plenty of other things that are related to smart cities and smart cities ontologies for digital twins with Gert and Miriam. That's today on the IoT Show. Hi, everyone. Thanks for joining the IoT Show. I'm Olivier, your host. And today, with Miriam and Gert, we'll talk about smart cities ontology for digital twins. Hey, guys. Thanks for joining the show today. How are you?
Hello. Fine. Thank you.
Thanks, Oliver.
Good. So let's do a round of introduction to start with. Miriam, you first. How are you? Who are you? What are you doing at Microsoft?
Yeah, thanks, Oliver. Thanks for having us on the IoT Show. I'm Miriam Berhane-Russam. I'm a senior program manager in the Azure IoT team. In specific, I'm part of the Azure Smart Places and Energy team, really focusing on smart buildings, cities, and the infrastructure that connects them, starting with the energy grid. And I focus in specific on smart cities.
Awesome. Gert, how about you? So who are you? Where are you calling us from, actually?
Hey, hello. Hello, Oliver. I'm calling from Belgium, actually Ghent in Belgium. I'm the CTO of Open and Agile Smart Cities, abbreviated to OASC. We work on what we call the minimal interoperability mechanism. So we work on a set of specifications for cities so they can implement solutions and scale those solutions across different cities and scale their solutions across even the globe if necessary. So that's what we are working on.
Okay, so Miriam, tell us a bit more about what your team is doing and why we brought Gert here to discuss these smart cities ontologies.
Yeah, so our team is working on digital twins for smart places and energy, and really looking at cities. The concept of digital twins, which really is a representation of environments brought to life with the integration of real-time data and IoT sensors, is really entering the realm of smart cities. As you know, last year we announced general availability of the Azure Digital Twin platform, which allows developers to model their connected environments and really bring them to life in an execution environment, and really drive with the integration of IoT data and other data sources. So to drive openness and interoperability, Azure Digital Twins comes with a digital twin definition language, which is an open source modeling language that allows modeling environments and really describing entities with the telemetry that they emit or the properties that they report or synchronize, as well as the command that they can respond to. But most of all, as well, it allows describing a relationship between entities. So to drive or accelerate developing digital twin solutions, it's our goal really to provide ontologies, DTDL-based ontologies for different domains. We've done it for smart buildings. This is for smart cities, so we'll be doing one for the energy grid. And really, we want to do that by adopting existing standards that exist out there, widely adopted. We don't want to reinvent anything, and really work with partners that are experts in the area to bring them into DTDL and then really make it available to the ecosystem. So for smart cities in particular, we've evaluated a number of different standards, frameworks, or ontologies, like the ETSI CIM NGSI-LD models, that developed by the FIWARE, OASC, and a lot of other communities in Europe. We've evaluated the ETSI Sirus for CD, CTGML, CIM, ISO, and others. And we decided really to start adopting the NGSI-LD because they were really close to the type of applications and use cases that we see in smart cities. And so then we worked with Gert, CTO of OASC, to really bring this and express it in DTDL. It's part of our approach is to really validate this. We're not trying to describe standards by the sake of describing standards, but really we want to prove that it works in the real world and it can actually power Azure Digital Twin-based solutions. And then obviously we want to open source it, make it available to the communities through GitHub repo. We're working with the Digital Twin Consortium really to drive it through that. And then we're also providing developer tools and documentation that can help really the rest of developers adapt or contribute to this ontology.
Great. So that leads to you, Gert. Tell me a bit more about what your teams are working on, because Miriam introduced that at a high level, but especially, what is ETSI NGSI-LD and how it relates to digital twins in general, and then to DTDL. And we'll talk a bit more about that integration or how we're bridging the two worlds of, what's going on with ETSI NGSI-LD and the digital twins world.
Yeah. Okay, great. As Miriam told, we based the model of the shared data models for smart cities on the NGSI-LD specification. The NGSI-LD specification is governed by ETSI, and ETSI is a European standards organization. It's one of the 3 organizations that actually can issue European standards, and it's one of the organizations that really focused on smart cities and streaming data in smart cities as a topic. For that, they created the NGSI-LD specification, which is actually then also is using JSON-LD quite heavily, and it allows cities to model their environments in various ways based on this open model. Big advantage is that you can actually interlink those models together and then, for example, connect a streetlight pole to a park where it also can be, for example, a waste bin. So the NGSI-LD specification allows that quite heavily, and then you have the fireware that created really open shared models based on it. And we use those models to make the initial mapping that we created now on the Azure Digital Twin in DTDL. They map quite nicely together because they are both based on JSON-LD, which is already great. So they both use the concept of context, which adds really definitions on the ontology you model in there. The big advantage is that they have similar items. Like, for example, in NGSI-LD, you have an entity which maps clearly to an interface on DTDL, but you also have relationships which both are based on, and you have properties. So the mapping was really straightforward, and it helped us a lot in getting these models up to speed for the smart city model. So I was quite happy to work on that. So we made an initial start of the modeling. There are a lot of more models, but we really want to rely on the community to help us build these further and further. But these are the ones that we already created. For example, we started with air quality observed, where you can have the location of where you measure air quality. You have the level of what the air quality is at that place, but also what are the specific things you're measuring there, the telemetry, CO2 measurements, all in there. The same, they're, for example, linked to weather observed because air quality is highly influenced by the weather. So you also have weather observed, where you can then have also the location where that weather is observed, and what then the telemetry of that weather is. What was the pressure? What's the humidity? What is the wind speed? So those are the things, for example, towards environment. But we also mapped, for example, parking. Parking spots in a city, an on-street parking, an off-street parking, how the model, who is issuing that parking, what are the different aspects of that parking. For example, is that parking geared towards children, or is it a bus parking? So all those things are mapped in that standard, and we brought them also to the smart city models that we are using on the Azure Digital Twin. And all together, these are linked, for example, towards a device, because those measurements are coming from devices that are measuring those things. So also that linkage is made, so we really know, okay, this device measured this type of things, and that's how we can interrelate things to each other. From that, we start the modeling. The tool we used, especially for that modeling, was Visual Studio. So should we switch? Okay, great. So Visual Studio helped us really in modeling these models. the big advantage is, since we had the context in our JSON-LD models, we really have, for example, intelligence. So if you're adding a property, we know these are the types of properties we can add. We can add a command, a component, a property, a relationship, a telemetry, which makes it really handy in modeling these things. It really helps you, the environment, in modeling thing. Of course, also the link with GitHub helps in adding things to GitHub, but okay. So we really took the models. One of the big advantages in DTDL is that you can extend models. So you can start from a base model where you have, for example, the basic things like location and address, which all the models have. And then you can extend it, for example, towards air quality observed, and have there, for example, the air quality index, but also the reliability, what type of location it is. All these things can be measured in there. We have telemetry.
Can I ask a question real quick here? So prior to that integration with DTDL, or the way we were actually mapping the ETSI and NGSI-LD models, or the way they were described there to DTDL, so were you like solely working in like pure JSON in your text editor, and now like you actually do the mapping and then you work with DTDL rather than work and just import the models from the existing NGSI LD definitions that exist?
We actually recreated the models because the model in DTDL is a bit more specific, and NGSI-LD also has a specific model. So we recreated the models, but based on the schematics that we had. So that thing that we did. Now we are in the process of recreating, but then it will be in a mapper for the real-time stream, where we automatically map an NGSI-LD stream towards a stream in Azure Digital Twins. And since they're both based on JSON-LD, that's possible. But for the static mapping, it's a bit more difficult because, for example, telemetry is not a separate model inside NGSI-LD. So you really need to identify which items are telemetry and then map them into a telemetry inside DTDL. So that made it not possible to do the transformation automatically in this aspect. But it will be possible for a real-time stream. So when we really get values in it, so not a static model, but a dynamic model, then we will be able to have an automatic transformation.
Go ahead, Miriam, sorry.
Yeah, so what this will allow as well, so now think of someone that's really starting on Azure Digital Twins and with DTDL. This becomes actually their starting point, right? So that's why it was very important to have a representation in DTDL. But as Gert said, right, we are also looking now at these converters, right, that actually then can allow us to federate multiple of the systems that talk in with that type of model. So at that point, we can map the NGSI-LD to DTDL in real time for real-time synchronizations of data.
Love it. And Gert, I know during preparation for this IoT show episode we discussed, I was asking you, hey, how did that tooling help you? And you just described that, in terms of the IntelliSense and the way editing a DTDL model in VS Code is very practical. You also mentioned the fact, and that's something that connects back into what Miriam mentioned in terms of the approach and how we're working with the ecosystem and the industry, and as well as the community for developing DTDL and evolving it. And you were mentioning an anecdote, about the fact that some semantics were missing, that you needed to express some values in a certain unit, and they were not available in DTDL. And there's that. What happened there? Can you tell me a bit more about that?
Yeah, so I'm actually in the screen right now at that point. So telemetry, for example, for air quality, CO2 is measured by micrograms. So it's very small substances per cube. So it's something you need for that modeling. At the point in time when we did the DTDL mapping, that density wasn't available yet. So and there was and at that point in time also no way to actually add these types of density towards the models. But yeah, since they're all on GitHub, also DTDL is on there. Actually, already an issue was created by somebody else who was also noticing this, and actually it was already picked up by the team, and they will probably if I'm not mistaken, they have put it on their roadmap and they will adapt it accordingly. So that's one of the big advantages, of course, if you do this in an open source way. I'm glad to be picked up.
So, and glad that the community is actually filing issues and contributing back. I think this is one of the things that we want to have. So great. So how about we look at something a bit closer, right? A use case for what we just described in terms of the smart cities ontologies use and integration with digital twins.
Yeah. So maybe I can talk about the smart pole use case. So one of the use cases that we find to be very interesting and strategic for a lot of cities is the streetlight infrastructure, where cities are already changing them to LED-based lights and then networking them really to save energy. So really huge from a sustainability perspective. But increasingly, we see it the poles really becoming some sort of a real estate, if you will, that starts housing and enabling a lot of the other smart cities scenarios. So, for example, environmental sensing, parking monitoring. Let's talk about parking and air quality. It could be EV. There could be EV charging attached to those poles. There could be all sorts of image sensing that gets done to different edge intelligence, like people counting, traffic counting, crowd flow counting. And they also get used for public Wi-Fi, 5G, and so on and so forth. So it's very rich, and we find it to be really interesting. So we started to really validate our ontology by taking an infrastructure like a smart pole and trying to understand how do we really model this, and how do we really associate all of this use cases or sensors, devices that are in there. And so we basically, Gert, showed you what's on my right side on the screen right now, where you already saw the models where we started. Like, we have models around streetlights and crowd flow, air quality, weather, noise level, parking spot, EV charging, and so on and so forth. Is that really the ETSI NGSI-LD provides in the one that we've adapted. So it was really quite useful to apply this. But one thing that needed really that the ETSI NGSI-LD models didn't include was this notion of how do you find a pole, and how do we find a pole structurally as an element, as an object within a city. And so that's where also the other standards that we mentioned come in play, and we started also looking at them and providing a mapping, at least providing a step for this. So as you can see to the left now, we've extended this with the Sirus for city, which really highlights the model of an administrative area of a city. So you can say, administrative area, city is an administrative area. You can say district is part of a city, and so on and so forth. But also it has a model for the city object. So, city object, there's a lot of city objects in the city. Actually, street furniture, things like poles, maybe bus stops and things like that, they're all furnitures. But then even if you look at buildings and bridges and other things, they all get classified as city objects. And Sirus for city then really uses the geosparkle topology model to really describe objects and the cities within some sort of a spatial object reference that allows to really create all sorts of containment of objects within a city. So you'd be able to say, hey, there's a city object, which is a pole. It's actually in a specific administrative area of a city. And this pattern, the topology model, is really used to rock that. And so what we've done is really compress this and add a pole, construct of a pole that extends street furniture. And then a pole can obviously be a lot of different poles. What we've done is we're interested about the light pole for now, so we've added the light pole, which extends like from a pole. This extension also allows us to really do inheritance type of thing. This is something that DTDL brings, so you can really model this as in an object-oriented manner, which really simplifies things. And then the light pole here, you can see that now we were able to link it to all the models that we have, to all the linked data from the ETSI CIM NGSI-LD. So we were able to really use the power of the ETSI CIM NGSI-LD together with the SRF4CD to describe something like a smart pole. Similarly, you can think that any sorts of infrastructure, it can be described in that way. And so we're welcome, as Gert called out earlier, for the community to extend. So I will show you an example real quick in our Azure Digital Twins, how we validated this. So what I have here, you see, is some of you might be familiar already. It's the Azure Digital Twin Explorer, which really can connect to an Azure Digital Twin instance, which I have it instantiated, the service. And then on the left here, you can see the models. You see, I've uploaded actually all the models from the ontology that I'm interested in building my solution. The Twin ADT Explorer is really handy because you can do everything from here. You can actually start uploading the models, and so that's what we've done. And it also validates it in real time, so you can see if there's any errors in your model. And then here, I really started instantiating, bringing to life a specific instance of a city, a district, and a pulse that I wanted to model. So in this example, in my example here, you see I have a city, Bellevue. I happen to be in Bellevue, so I decided to just use that as an example. You can see here I have a couple of districts, District 1, District 2. In fact, these concepts are from the Sirus that I showed in that diagram. And then you see in my districts now, I have these poles that basically are the smart poles. And so these are also modeled from the city object. And then in each of these poles, I've attached some of the NGSI-LD models, like streetlights, for example. You see this is a straight light one. And as I click on this, you see also on the right, all the properties, components, relationship of these models also show up. So for example, when I clicked a streetlight, you can see that, all the properties show up in the right. You start to see like energy savings and all the parameters that streetlights are interested, but you can also see here their air quality one that Gert was showing, right? So here you see that there are a lot of things that we're interested to monitor attached to this district. So pretty much you can continue really building this example this way. One of the things that becomes really interesting and ADT really brings to power now is, for example, I might be interested to monitor energy level or consumption at the city level or at the district level. What I would be able to do is really take the values from the energy consumption from each of those nodes. So for example, attached to a pole, there could be EV chargers, there could be the streetlight itself, and other energy services. And then I can actually start creating computed values, or actually the notion of key performance indicators that will then actually extend it in the ontology and be able to understand those KPIs as attached to the district and or city level. And so you'd be able to drive compute on top of this ADT graph based structure, and then really do all sorts of cool computations. So with that, we will provide this samples, but anyone can really now take this ontology and start building your solutions with it.
I love it. Thanks, Miriam. That was very detailed. And one thing you really highlighted here, and I really like, is that Azure Digital Twins is not an end. It's really a tool for building applications that will take advantage of all that data that is being actually accessible now through that ADT graph, and thanks to these models that have been imported. So that's pretty powerful. And it's, I would say, just the beginning of broader applications, right?
Yeah, absolutely. And I think one thing that we really want to highlight now is, obviously, as we said, we want to accelerate development of digital twin solution. But with the ontologies, really where we're going is enabling the interoperability of the ecosystem. So if you look at the city, right, even if you look at the pole, there are going to be multiple provider of those capabilities, whether it's a street light or EV charger or the air quality monitors and so on and so forth. What this allows is a developer or city that's actually integrating all this data in a digital twin-based solution can use the standardized data, right, this ontologies to really then start acquiring all the data from providers according to the specific meaning that the integration will expect. So that's why it's very key for us to bring really these ontologies to drive the interoperability at large in the ecosystem.
And what's maybe also important to add there is that we can now also interlink these different ontologies. Like, for example, you have the real estate core, which is really based on buildings. We can now link it towards the smart city ontologies and use those models together and really interlink those together and make those ontologies greater. Also, it led to OASC also talking to real estate core to incorporate also that standard there and then provide it towards the city. So it's really an ecosystem that helps each other and broadens the adoption of those standards across the ecosystem, which is really great.
Yeah. And well, that's great, guys. And I'm going to do something is I'm going to fix something live here because I did mess up on that link that was displayed below, but that's fine. We'll keep that. It's part of life. And so for seeing that that interoperability and that community work happen, there's that GitHub repo down there. So if you go to aka.ms/IoT show/smart cities ontology for digital twins, you'll get to see all the good work that is happening there, allowing implementing these very rich applications to take advantage of that interoperability and that integration of various sources of data in the realm of smart cities. Miriam, Gert, thanks a lot for your time. Thanks a lot for a very insightful show today. I hope to see you soon again on the show. Same thing for you guys. If you have not yet signed up for the IoT show, don't forget to subscribe and see you soon. Bye. See you.
Bye.
Bye.